All right, so I think maybe we should start. Am I audible, everybody? All right, perfect. So my name is Aritra, and thank you for taking the time to listen to this presentation. I'm based out of Stockholm, so pretty cold from here. I would say it's 10 degrees there. And yeah, so in the next 20 to 25 minutes, we are gonna do some advanced stuff of observability and discuss something about monitoring. So the assumption of this talk is like we have a basic understanding of what AWS is, or what containers is, or what infrastructure as a service is. A little bit about myself. Around 13 to 14 years in the industry, working with one of the partners of AWS called Playground Tech. And that's my daytime job, and in the evening normally I spend time with the community doing some AWS work, solutions, working with presentations, write some blogs and everything. So I am also part of two cohorts of AWS, that is community builder as well as ambassador. And in the last month, AWS also recognized me as one of their stars in the certification realm. And it's my wife who is accompanying me in Stockholm, so we normally tend to spend our off time trekking around the different parts of Europe. So this one is last week in the Dolomites. It's one of the really good lake that is, we went up there. So moving on today's agenda, so we will start off by discussing about what is observability, the term that came up I think in the 2019 reInvent, if I remember it correctly, and why Opentelemetry is one of the things that is really a crucial component going forward in this landscape. Some of the production grade solution designs that we have deployed in multiple customers using Opentelemetry and handling their observability. And last but we'll showcase one of the demos, and then we'll end off the sessions, leaving up the forum for some questions and some clarifications. All good? All right. Just one word to note. So it will not be fully presentation. I don't want to bore you with the PowerPoint. So from time to time I'll try to switch the screen between some of the AWS console and try to show you some boilerplate codes as well. Perfect. So moving on to the first, what is observability? So what we found out is this coined term in the world of cloud basically consists of three signals. So the first is metrics, which basically helps us to detect what is happening within the system, and there are like multiple SaaS provider like Splunk, Datadog, which basically helps us to visualize those metrics. One of the second one is logs, and we are all familiar with this, and I am pretty much sure all the developers at some point of time might have to go and diagnose all those lines of codes and all those lines coming into the consoles using anything like Kibana, or for example normal JSON file or CSV files as well. The third signal which has really come up in the microservices world is called traces. And basically what traces does is to isolate you whenever there is a request and response involved. So for example, the mean time to response, what are the metadatas involved with this, and these three signals basically what it does is it's collaborate into something called observability. And on my right side of the screen you can just see an example from the Datadog, that how does a production system work. So it contains the matrix, it contains a visualization of matrix, it gives you near real-time logs, and also it helps you to monitor and have traces on top of it. Now coming to one of the very big confusion is like all this are very much tending towards monitoring, because we used to have systems which were ironclad with monitoring setup, which we had on calls, we had all sort of systems kicking off when there was an outage inside the system. But all of those I would say falls under the monitoring, and what observability does is, like as you can see from the iceberg setup, it fishes out, it helps you find all the insights that is running within the system, and eventually the end goal is how do you observe, how do you basically advance, how do you improve your system. So some of the basic differences is in monitoring is like, what is my system working? We have pager duties set up, we have on calls, we have Slack alerts and everything that basically starts firing when my system is not working. Where observability speaks about what is my system doing, how I can improve it, or is it deployed multi-region, is my customers getting mean time to response and everything. The second point is basically, sorry, I think maybe I'll shift it to this one. The second point is basically, as I told you, like monitoring tells us like when my system is wrong, whereas observability is when you set it up with some event rules, automations and everything. It basically gives you a much more bigger insights like why my system is wrong. The third part is, as you all know, like monitoring is basically reactive in a nature. So you have some SLAs, you have some system sitting on call, which basically tries whenever some issues happens, whenever some outages happens, they comes in, the whole system kicks in, the backup system kicks in, the discussions kicks in and everything. So why something went wrong, whereas observability is much proactive in nature, and with all this AWS or GCP or Azure or all those cloud coming into the picture, it has become much more reactive. So the last part is basically the difference is one of the thing, it enables like quick response monitoring, and observability basically reduces the duration of the impact. So going ahead, we would see in the AWS world, and I'm pretty much sure it's evident for other public cloud hyperscaler as well, that there will be reducing in the downtime and everything with observability when the system becomes much and much more adopt, and they try to adopt the signals of observability. Now coming back to my first point again of why observability and how does it relates to Opentelemetry. So once we started seeing a shift back in 2019, we saw that different vendors started making their own way of making an observability systems. There was a community which were making some sort of a vendor agnostic format called Open Census, so which was basically shipping out the metrics from the systems and deploying it into a backend. Then the second one came into the picture called Open Tracing. So it was mostly focusing on when there was a request response based systems, when there were multiple microservices involved, how do you make a singular format for traceability. But later on, I think probably at the end of 2019 or 2020, both the communities actually understood that it's all tending towards a similar agenda or motivation, and that was to improve the system, improve the monitoring of the system, and that's how Opentelemetry was born. And that's how this whole, and even if you nowadays go to the GitHub of Open Tracing and Open Census, it's still alive, even though both of them are archived, but this Opentelemetry is right now in an incubation stage, and it is forked from both of these GitHub repositories. But the question comes to us is like, what is the advantage of Opentelemetry? Why do we need to, why did it actually came up, and why all the customers that we have seen have started to embrace this one? So the first one is like, as I mentioned, like each of the SaaS vendors, be it like Dynatrace, New Relic, Datadog, we used to see that they had their own way of actually tackling those signals. So they had like their own SDKs. Datadog has its API, some of the vendors had its own token, then you need to re-instrument your code on the way that they actually accept those formats. And whereas Opentelemetry basically took away all the hassle. So I will showcase to you like how easy it is to basically spin up this and initialize it. So it's like one single application, one single SDK code of Opentelemetry that we need to adopt into our application, and then it will give you all the things out of the box. So basically what happened is like all the applications started getting themselves decoupled from all the vendors. So the applications, even though they started shipping out those metrics, they became vendor agnostic. And the second thing is it gave us more data control. So normally what we have done in AWS is like we have a single source of truth, like how to ship out those data. and that became and that made us much more easier to ensure that we have a proper visibility on the data, we have a proper tackle on the cost, because what happens is like when we start shipping out data, when there is a data ingress outgress cost that gets involved, the data transfer cost involved, because metrics are data which needs to be ingested into the SaaS vendors in a real time, because if it's not real time, or if it doesn't get visualized to us immediately, it's not evident, because then we would see some lag, or there would have been some monitoring issues or something like that. So it gave us more data control. It gave us a singular format of tackling or instrumenting our data to adopt those signals. And the last thing is, out of the box, it gave us pretty much support. So for example, whenever a database was happening, a database is adopted into the application, it gives us a support of what sort of an error is happening. All the normal semantics that we use in a microservices world or in any language, be it Python, be it Java, be it anything, all those semantics are already handled by this. And the good part is like this project of Opentelemetry is still in a incubation stage. So there is like huge amount of communities work still going on there. And the thing is like there are projects that are going on, and developers are still nowadays checking in and doing some PR requests on those GitHub repository to constantly evolve on top of it. Now coming to the Opentelemetry components, as I mentioned, like it's not like a clicky work that we need to do in console. It's a re-instrumentation of the code. So these are primarily the components. So we have to have an API here. We need to have a telemetric sampler, and we need to basically export and convert and send them. But what happens is like in the production based application, we normally take out some part of that. We basically merge the exporter and the collector as a separate entity, so that our application becomes much more lightweight. So we just adopt and we just ship it out. And at some point of my presentation, I'll show you how we have done that with AWS. And the last part of this whole component with this chain is the monitoring backend. And it can be any tool. As I mentioned, the whole system, this till the collector, it's a vendor independent. So what happens is like your monitoring backend becomes flexible, and the main advantage for the customers is like they are not tied up with anything. So today, let's say if the code is made in Opentelemetric way, today they might used to choose vendor 1, but if they see like the cost gets increased or there is some issue, they might change it immediately to vendor 2 without making any change in the application. So that's the whole picture or the whole train of how Opentelemetry works. Now I'm gonna switch my console, just gonna show you how easy is it to make a tracing component inside an application. So here I have a Python application. Oh, let me exit. Go here. So here I have a Python application. So here, if you can see, so what we have to do is basically we have to adopt or integrate our Opentelemetry SDKs, and then we have some resource created, and this resource is nothing but shipping out some metadata. So you can create some more metadata into it and everything. And then we just add those tracing provider, and then just run it with a tracer. So with 4 to 5 lines of code, you will get to see when I run or when I execute this one. What are the advantages that we have? So we get like a trace ID which is automatically generated. We also get like a recursive, or we also have the provision to have a recursive trace. So if it is already coming from a parent trace, it actually adds that inside that. It has a start time, end time already integrated into it. So we don't have to create our code like, okay, this is a start time. And apart from that also, it gives you all the things like what sort of a language is it, what sort of a version is it, if there is any metadata or if there is anything that is involved. And so So this way in Python it's pretty much easy, and I'll show you on the later part like how we have done with the Java and Java as well. But this is why one of the advantage, or I would say the Opentelemetry is coming up so much in the nowadays, and customers have started adopting it, and it's being used large scale. And from the AWS part, I can also say like they are constantly evolving. They have come up with some managed services as well, which I'll showcase to you. Now coming to the main production deployment part, how do we actually do it? So there are two ways that we have achieved this one. So the first part is out of the box, AWS gives us something called a AWS Opentelemetry A collector. So that happens is like you basically attach it as a sidecar inside the main container, and that ends up shifting or shipping out all the data to Prometheus, X-Rays or Grafana or whatever that you need. But the disadvantage of this that we found out is like with the increment of the services and which each of the A collector adding as a sidecar inside that. So what it happened was like basically it ended up a huge amount of data that we need to instrument inside the monitoring backend. So the vendor that was responsible for visualizing, so there was like loads amount of data which we need to basically ignore it, or we need to basically re-architect the whole dashboards. So that was one of the disadvantage of using this sidecar pattern. So what we did was we moved to another pattern, and that is where which I believe it's a much more cleaner way of approaching, and it's much better way. So what we do is like we have a Opentelemetry standalone service which doesn't contain any application, which doesn't contain anything, but what it contains is like it contains the data control configuration. So if you remember, we have a data control, one of the parameter of Opentelemetry. So that we basically inject into the Opentelemetry, and we register this service in the cloud map, and the cloud map is nothing but a service discovery, so that any other services even outside of the account, if it's part of the same VPC, or if the VPC peering is done, it's able to resolve it. So what happened in that is like basically your application became independent of whatever Opentelemetry configurations that you required. You had got a single source of truth. You had much more control of your shipping out of the data, and the applications just had to consume the endpoint. And I'll show it to you how we do that in the service. But this is now much more cleaner approach, and your code can basically and your Opentelemetry services basically can cater to any services that is inside the cluster, that is outside the cluster, as long as it gets resolved in the cloud map. So now I'm going to show you the console. So for the interest of the time, I basically have spin up all the code, but I have a reference which I have wrote. So in that blog you have all the configurations. So basically this is my Opentelemetry service. So here if you see, I have the jar which is provided by AWS out of the box for making all the configurations, and here I have the environment variable which is basically giving me all the control of, or how do I basically ship out, or how do I basically make the data. Do I ship it out in batches? Do I send some data? Do I remove some data? And basically that is how you do. And this service gets resolved in this cloud map, and what it does is like we have a namespace, and in this namespace whatever namespace is calling this hotel service are able to get those calls and start shipping those data. And in the task configuration of whatever services that we use, if you see here, we have this hotel service endpoint, and we make our application decoupled from whatever configuration that we need to do. So we just inject the hotel service endpoint. We just have some metadata like, okay, if it's a Fargate service or whatever, and that's how it starts shipping the data. And I'm going to show you how does it work or look in the real life. So if you see here, this is one of the dashboards in AWS. So you have so many of the data and so many of the metrics that is also already coming in. your code is formatted in the Opentelemetry logs format. So it has its own formatting, it has this traces and everything already injected on top of it, and you can basically get some custom metrics as well. So if you need, you can get some custom metrics as well. So this is how easy it is to ship out. Now for the last part of my presentation, we also have something called tracing. If you remember the traces, how it works. So what we have used here, what we use in the AWS world is something called AWS X-ray. And X-ray, the advantage of X-ray is like if it's a multi services or microservices that spans across multiple system, it basically gives you the whole parent based tracing, and in some time you will see how amazing it is. So but the thing is how you do it, like you follow the same approach. So you instrument your code, you add some sampling rules, and then you end up hosting the service. So this is how we normally do in Java. So we basically write a static block of code where we mention the sampling rules, and the sampling rules are nothing but, it normally depends like what sort of a request that we need to capture. If we need to capture all the requests in batch, or if we need to filter out some of the requests that we don't need to capture. But this configuration basically you can either set it per Java per application, or you can basically spin it, or you can basically ship it out as library itself. So in the normal demo world, what we do is like we have a application which has an endpoint and which basically has a VPC and inside that VPC we have a Fargate container, and in that Fargate container we have done is like we have a DynamoDB. We just like putting some dummy data to show you like how it happens, and then we put something on the S3 as well, and I'll show it to you like whenever the request happens from this endpoint, how this whole thing spans across multiple metadata gets added, and even it gives you the response of what it comes from DynamoDB, or if we have some failure inside the system as well. So this is how the application is. So it's a simple Java application which basically has some client calling other application just to mock a real life scenario, and each of these application basically has some other third-party clients. So one of them calls an third-party API, one of them does a DynamoDB update, one of them puts some data onto S3, and I have manually deliberately failed this application. So when I'll show it to you, you will see that this part will fail because there is no schema present. But you can see like from this request, all this thing will get tracked in. So what it happens is like it basically, as I mentioned, it has a configuration to AWS and it sends all the tracing data. You will start seeing it reflecting in the X-ray console, and in this console, if you see, it has already generated a tracing for us. And based on the configuration that we have done, so if you see here, it basically gives you the whole like tracking and traceability. Like it calls a third-party endpoint, it calls the DynamoDB, it basically pulls the data into S3. And as I told you, like I deliberately deleted one of the endpoints here, so you can even see that this gets reflected here. And if you basically go down, you can see like what sort of a response code has happened and what sort of a duration is taking for each of them. And in this fault, you can see that we have the exception that we have deliberately deleted this schema. So from one console, instead of going through the code, you can debug the whole application so easily using this tracing. So this is one of the advantages that observability gives us. So you don't need to go through multiple systems, you don't need to basically deep dive into your code, but just like making sure your system has Opentelemetry, your system has tracing adopted, you can basically find out the error and start working accordingly. The last part of my thing is like, because one thing is like cost and usages is really important here, because both of them are managed services from AWS and there are some cost involved in it. And what we have seen is like when we make a system which is like sampling 100% of the rate, it's shipping out all the data, it's a highly running system, like for example 1000 requests per minute. So it's highly unlikely system running 1000 requests per minute, we sample 100% of the data. We might only sample some of the main APIs like authentications and everything. It costs around $250 per month. And similarly it goes for CloudWatch as well. So with a huge amount of data, with 1 GB of log volume, and even though that's pretty much highly unlikely, we don't ship out 1 GB of log volume per day, it's pretty much less, it's around $80. So I mean, if I basically give out a ballpark figure, so within $300 to $320 you can basically create an observability system which would be much more improved, and it would be self-aware. The last part of this is some of the references which I mentioned, which might help you to basically go through and understand all of this. Some of them are from AWS workshops, some of them are from my own learnings and my own mistakes, and on my own implementations that I have done on the customer's work. And yeah, so that's it. So I open up the forum if you have any questions.
For the bottom of having the Opentelemetry service and the configuration parameters separated, you said that in the configuration is where you configure things that what you want to ship and everything. So I understand that configuration of the log streams and metrics. So for example, if I want to not send the log log to the backend, I can just set up that.
Exactly. So all those sort of things will be metric, and even though in certain cases, if you saw the dashboard that I showed, we ignored a whole lot of metrics as well, because in the more matrices that we ship out, it actually costs us more. So via that single configuration, we can actually make it much more resilient and tackle the cost factor as well.
If I want to anonymize the log data, do you think you have a solution already in there, or is that something I should do elsewhere?
Sorry, what do you mean by anonymize?
Well, if I have banking data, for example, and I want logs from that banking data, I don't want certain information to be in the log.
That's a very good question. So what we normally do is like the Opentelemetry itself is not aware of what sort of data are like censored, what sort of data that needs to be censored. So it's on the application side, you need to re-instrument your code. So you need to basically adapt some of the logs, you need to either use some decoder, or you need to basically mask those data on the application side. But Opentelemetry itself, the platform is not aware of how do we do that.
For Kubernetes, is it possible to implement Opentelemetry without central container?
Yes, yeah, we have already started doing that with one of the big betting customers in the AWS world. So the only thing with Kubernetes is like, as long as you have the endpoints resolved, as long as it's able to connect to the endpoint, and as long as you are able to host that Opentelemetry service either as a part of a separate pod or separate deployments, it should be good enough.
The metrics, how long usually you keep the metrics for, like 30 days, maybe, or?
Yeah, that's a very valid question again. So that also depends on what is the contract that you have with your observability monitoring backend services. But normally for AWS, I can tell you that totally that's on the infrastructure side, or that's on the agreement or the GDPR setup that you have. So for example, you can keep those as long as you want, like for 90 days or something like that. Or for example, I know AWS by default has some retention period. So after that, it basically gets deleted from the console. But again, I mean, that's part of the monitoring backend setup that you need to do. I mean, our Opentelemetry and the microservices are basically not aware of how do you save those things.